let's look at this problem from 2018 AMC 10A. It's problem 18. How many non-negative integers can be written in the form of this entire expression where a sub I is either -1, 0, or 1? For 0 less than or equal to I less than or equal to 7. We have 5 options here. Now firstly, notice that the 5 options A, B, C, D, E are all pretty large numbers. Like they're 5, like the smallest is 512. So this means that we can't manually list out all the possibilities and count them up. It's going to take a lot of time. Well, unless you're stuck on the problem, all the other problems, and you have like 1 hour left to do this. But otherwise, we should use some quick math trick to solve this. So firstly, what does the expression remind you of? Well, notice that it has 3 to the power of 7 to 3 to the power of 0. All these 3 to the powers of something. So this should remind you of, or in the future, it will remind you of the base 3 system. So you should have learned the base 3 number system. If you haven't, then learn it now. So the base 3 number system is basically writing stuff such that it only includes 3 digits, 0, 1, or 2. So the base 10 number system is writing stuff that includes digits 0 to 9, right? 0 to 9. Base 3, so this is the base 10 system. Base 3 is 0 to 2. Now what about some other bases then? For example, base 5 would be 0 to 4. So that, etc. And when we convert from base 3 into base 10, we write each digit. So this base 3 number would have been A7, A6, A5, A4, all the way to A0. And this should have been the base 3 number. And now when we convert into base 10, we write it out like this. We add all the numbers up and we get the base 10 representation of this number. So how does this actually help us? So it's like making stuff more confusing, right? Like we were using base 10 all along, and now we have base 3, which is making the problem more confusing. Well, no, it actually isn't, because we know that if we're writing numbers in base 3 and the largest number is, well, if you use all ones, you get the largest number, which is just 1, 1, 1, 1, 1, 1, 1, 1. So 8 ones, because there's 8 digits, so A0 to A7. So this is the largest number that this whole expression can produce. And this is equal to 3 to the power of 7 to 3 to the power of 0 summed up. So it's 3 to the power of 7 to 3 to the power of 0 summed up in base 10. So what is that? That's just 2,187. So 2187 plus 729 plus so 243 plus 81 plus 27 plus 9 plus 3. And then don't forget the 1, because this is 3 to the power of 0, which is just 1. So we sum all of this up, we get 3,280. So I've done the math earlier, so yeah. So the math is not that hard here. It's just be careful. So it looks like we're really close to this answer. But we have to verify first, because in AMC 10, if you don't choose, you actually get 1.5 more points than if you choose the answer and get it wrong. So you have to actually verify the answer to make sure it's right. So how do we get the extra 1? Well, firstly, why do we get this? Why do we want this? Because essentially, we realize that using these 3 numbers for a sub I, we can write all the numbers from 0 to 111, so 211111111 base 3, using these 3 numbers as digits. So how do you use -1 as a digit? You're probably going to ask. Well, we don't use that as digits. So we don't use that as digits. For example, we use it to make 2, because right now we don't have 0, 1, 2. Base 3 has digits 0 to 2. So the -1 is to represent 2. So how do we do so? For example, you have 1 times 3 to the power of 7. So A7 is 1. And then you have 1 times 3 to the power of 6. Right? And then let's say you have -1 times 3 to the power of 5. And then So how is this going to help then? So you have some other stuff here. Well, essentially what happens here when you try to make this digit positive is you can write this number as 3 times 3 to the power of 5, right? So when you factor out 3 to the power of 5 over here, what you get is 1 times 3 to the power of 7 plus 0 times 3 to the power of 6 plus 2 times 3 to the power of 5. So this is how you get 2. And you can represent, and you can make all the digits have 2 in this case. So this is how you can represent all the numbers from 0 up to 1 in base 3. So there are 3,280 numbers from 1 to this huge number over here in base 3. If you convert it to base 10, this much numbers. So why is the answer over here 3,281? Because in this case, when we calculated this, we didn't include the possibility that we could have all zeros. So we didn't include the number 0 in base 3 when we calculated 3,280. Because when you calculate, this number is basically counting up to 3,280 from 1. So there's 3,280 numbers from 1 to 3,280, right? Which is how we count. However, we forgot to include the 0, which is also a possible case here. So to include 0 as a number, as a possibility, we add 1 to make it a total of 3,281 possibilities, which is the answer. Or you can think of it as, how much numbers are there between 3,280 and 0? Well, you just do this subtraction and plus 1, which is again 3,281. So the answer is D. So thanks for watching. Bye.